does not affect the probability of event B. If that holds true, then these two events are actually independent events. If the occurrence of A, the happening, does not alter or affect the probability of B occurring. I'll say it again, because I know why you're copying it. What does it mean for two events to be independent events? A and B are independent events. If the occurrence of A does not alter or affect the probability of B occurring.
So do they have to be mutually exclusive then?
No, and they don't have to be mutually exclusive, and I don't even want to throw that word out now, Art.
Okay.
So anybody gets confused, but I love your question, because we can think of some relationship between these two, between mutually exclusive events and independent events. But right now, I just want us to really concentrate on this new word, which is independent events. So, everyone, anybody got a coin on them? Let's say I got a coin right here, and I'm flipping it. It's going to land either heads or what?
Tail.
Tails. I keep doing it. Now, do you agree I got a 50% chance it's going to be heads? Right. 50% chance it's going to be tails. I keep flipping this. And I keep flipping this, and let's say I win money every time it lands on heads. Do you think if I played it all day, I'd get really good? I'd get really good at this game, and I would improve my chances of it being heads? No. That's because the events of just flipping that coin are independent events, right? The occurrence of the first few times I flipped it did not affect the what? The probability that I would win later. Do you agree? 5 hours later, everyone, I just keep putting, you're still, Professor Messenger, stop. Your chances of it being heads is still going to be what? 50%. They're called independent events. Now listen to this. Let's say I said event A is earning a bachelor's degree. There's a lot of people in this room. You're going to finish your degree here or working on your bachelor's degree. So I'm just going to put earning a bachelor's degree. That's event A. And I'm talking about event B. Just earn more than $100,000 in a year. And these are my two events. Well, I hope you agree with me that these two events here are not independent. Because earning a bachelor's degree, all right, can actually affect my chances of making more than what? $100,000 a year. We all know what? It's not guaranteed. I mean, do you agree with me? Who knows people who don't have bachelor's degree that make more than $100,000? Me too. And they make millions, don't they? Right. But we're saying it's all about this word chance and likelihood and probability, right? That's the wording. So that's why right here I get this word probability. Two events are independent events. If the occurrence of A affects the probability of B, then those events are not independent, they're actually dependent, right? The idea, yeah, you're in a brush, actually have a chance of making that $100,000 per year, have better odds of that. We're not saying it's guaranteed though. As you can see, everyone's like, hold up. I know a person, they got their PhD, and they don't make $100,000. But I know my other friend, I know this person, and they make $52 million a year. Yeah, and they didn't even finish high school, right? But it's all about probability and chance. Cool. All right, so, hey, have you ever seen, I'll step away from the cards now. Have you ever seen a roulette wheel? Mm-hmm. So I need to show you an image of this. I was going to pull it up there, but this would be quicker because there's a picture of this in a textbook, and a lot of you have your textbook. And when on page 266 at the top, there's a picture of a roulette wheel. So at the top left of page 266, I figure that'll be faster. You can see this actual roulette wheel. And I'm going to put down what's on this roulette wheel. There are numbers, but there's colors, reds and blacks, and there's a green. There are 18 reds. There's 18 black slots, and there's 2 green slots. You go, do I have to memorize that? No. I know. Understand the cards, but you wouldn't have to memorize this. But there are 18 red slots. There are 18 black slots. There are 2 green slots. And do we have casinos in Maryland?
Mm-hmm.
Yeah. Do they have roulette wheels?
Yeah.
And a lot of people go over and play it. And it's like, all right, I'm going to bet $5 on black. And he drops the wheel spins, right? Drops the little ball in there and it circles around. The wheel starts slowing down and that little ball falls finally in a slot, right? And if it's a red slot, okay, black slot, whatever, and you're saying if I win or lose. So here's my question. Are these events of me just playing this game over and over and over again, are those independent events?
Mm-hmm.
Do you agree? I mean, it's the idea, like, if I keep playing it, I'll get better at that game. Yeah, you're all like, no, they're independent events. It's like flipping a coin. Right? The occurrence of the first 5 times I played it does not affect the what? The next one. Although, everyone, if you're curious, in this world, has that ever happened where they weren't really independent? Yeah, actually, I mean, this is a true story. True story. I mean, some of the roulette wheels, especially in Europe, over time, made out of wood, over time can what? Warp a little bit?
Mm-hmm.
Might not be totally level. And so this family, started with the father, he would go in and they would just sit there near the roulette wheel and write down on a piece of paper all the numbers that came up for like an hour straight. Right? They go back to the hotel room, tally up all the numbers to see which numbers are coming up more often than the others. Now why was this happening? Because what happened to that level roulette wheel? It was made of, it kind of warped a little bit. And when they made thousands and thousands and thousands of dollars doing this. Because they knew which numbers would come up what? More often. So true story, I mean, you can probably find this on YouTube. Eventually he wanted to do this in Las Vegas. So and when he took his family out of college to work with them. He took them out of college. They would do this. They'd go to casino, working like pairs. And they would just write all the numbers, go back, what have we got? All right, let's bet money on either red or bet blood on sevens. Made a ton of money, but when he went to Las Vegas, okay, don't they have cameras everywhere and stuff like this? Or they spotted him like within an hour. We got people counting the stuff, they're watching over here and all that. Even though I'm sure they study that roulette wheel every day, make sure it's totally level. But they caught him and, because they might have been doing something else. They might have been counting stuff like even the blackjack cards. So when they put him up, and when he almost had he didn't have a heart attack, but he really did have a serious episode and stuff. So he basically retired after that. But so can I just throw you out of a casino? Yeah, He wasn't doing anything illegal. That's what I like about this. He's just thinking I like that he's using probability. But they have the authority to just throw you out of it, and say, hey, now we get your face, we don't want you to come back
Didn't
here.
a bunch of kids from MIT did that?
Oh, that's a great story. Let me see the movie 21. Let me see the movie 20. Yeah. So he's talking about the kids from MIT doing stuff like this.
Yeah.
But this, when we're going to consider, you got a level board, it's basically independent. So here's my question. What's the probability? It falls on red 3 consecutive times. So that means that when I'm going to play this game 3 times in a row, I'm betting on red each time. I'm betting on red, I'm betting on red, I'm betting on red. I want to know the chances that I can win this 3 times in a row. That it's going to land on red, then land on red, and land on red. By the way, you read this. 3 consecutive times means 3 times in a row. In a row. That's what it means. So when you read this, you might be thinking, do I have or do I have and? And you may want to put this in your own wording. So when you and I read this, what's the probability it falls on red 3 consecutive times? That doesn't mean it lands on red, or then it lands on red, or then it lands. This means it lands on red, and
red.
lands on red, and lands on red. You follow me? So that's why we're going to multiply these. And we said we're allowed to because they're independent events. So I'm going to get my parentheses right. Okay, I'm getting it all ready. Now what's the chances it lands on red? Remember, we got to make this a fraction.
So
What's the total number of events here?
18 over 38.
So we're looking at the total number of slots, right? What's 18 plus 2?
38.
38. So hey, if I did present this on a test, because I said you don't have to memorize that, but you would have to add these up to get this what? 38, right? All right, now, how many red slots were there?
18.
Okay. So isn't that the chances it lands on red the first time? But then I just do what? Now when I'm writing this out the long way, I know there's people in the class right now, they go, I've got a faster way to type this on a calculator. But I'm not gonna, I'm okay, I can type it out like this on my test, I'm gonna get full credit. I'll just take it slowly, just make sure I put these parentheses, right? Don't round early though, right on? Like we're gonna write all, I'll do it like that. Now, who in this class has just a slightly quicker way to type that in on a calculator?
Cube.
I heard it. And when can I write this as 18 over 38, close the parentheses, raised to the third power, right? So I'm going to write it that way in case someone in here prefers that. I just ask you to be careful because, watch this. I would hate for a student to go, oh, I know how to do this. It's 18 over 38 cubed, and they accidentally do that. No, that's not right. That is not right. Does anyone see that? Do not do that. You're going, oh, I'm not doing that. That's not what it means. It means, ready, raise to the third. So how do you get this raise to the third on your calculator? There's a caret button. There's a caret button. It means it'll raise it to the third power. 18 over 3. So I'm curious, what comes up?
11%.
So I'm going to squiggle. Because I don't think, Autumn, in this case, the numerator and denominator get so daggone big. Let's just go ahead and approximate what this comes out to be. 0.11, what was after the 1,
It's like 0.106, so 11%.
Oh, so it came out to 0.106. So we're saying there's roughly an 11% chance, right? That this happens. Cool? I love it. Now, if you want to do it this way on your, that's fine. Just be careful, true? But there's nothing wrong with doing it the wrong way. Now, something else. When you do this, make sure you put what around the 18 over 38. Because order of operations. Boy, is that order of operations so important in statistics class. Because we're always using these calculators. And if I didn't put the parentheses, the calculator, if I wrote 18 divide 38, raise the calculator is only going to put the 38 to the third. Does that make sense? Cool. All right, I got another one. What's the probability it falls on red 6 consecutive times?
That's even less.
What's the probability it falls on red 6 consecutive times?
18 over 38 to the power 6.
Well, what would be the long way? 18 over 38. 18 over 38. You're like, man, you're doing it the long way. Well, I'm playing it safe. 18 over 38, and finally, do you all agree every time I keep multiplying these, 1, 2, 3, 4, 5, 6, the odds keep getting smaller and smaller and smaller? I love it.
So
But what's the fast way?
1%. Or to the
To
power
the 6 power? Point 0,
6. 0.
0,
No, 0.011.
0.011, so roughly a
1%.
1% chance. So everyone, can I ask you a question? Would this be unusual? How about for our class, we're going to consider anything under 5% chance unusual. Does that sound good for our class? So that'll be our standard. We'll say anything under 5% chance we'll consider as unusual. So would it be unusual for this to happen?
Yes.
It would. But could it happen? Yeah, you go, it could happen, but it'd be very unusual. You only have a 1% chance of that happening. Cool. Hey, we barely got into 5.3. So I don't want you to think like, oh, I can do all the 5.3 sections. I mean, we just barely got into it. So next class, we really did 5.1, 5.2. We're going to start with 5.3 on Monday. And have a great weekend.